Hi friends, so we're talking about compound meters today. Recall that previously we studied simple meters where the top number is 2, 3, or 4, and it always told us the number of beats per bar. Well, I'm going to rock your world today and show you some different kinds of meters where the top number is 6, 9, or 12, and they work a little differently. Let's take a look at some slides. So now we're studying compound meters where the top number indicates the number of divisions per bar. The top number for compound meters will always be 6, 9, or 12. Here's a little chart I've prepared to show you the difference between simple and compound meters. Notice that for simple meters, the top number tells us the number of beats per bar. 2, 3, or 4. That also tells us the conducting pattern we use. Well, for compound meters, the top number does not tell us the number of beats per bar, but rather the number of divisions per bar. So the numbers are greater, 6, 9, or 12. And what you want to remember for compound meters is that we group these divisions into groups of 3, not 2. Then the bottom number tells us, for compound meters, the value of the division rather than the value of the beat, as it is for simple meters. Let's try a few examples to see how these work. So let's start with 9, 8. Here are the 3 questions we need to answer: the number of beats per bar, the value of the beat, and what the division level is. If you want to determine the number of beats per bar for a compound meter, all you have to do is divide the top number by 3. In this case, for 9, 8, if we divide 9 by 3, we get 3. There will be 3 beats per bar in any meter whose top number is 9. And we will use the conducting pattern of 3, the triple conducting pattern, for these meters. Now I want to skip the second question, the value of the beat, because it's not immediately apparent when we see a compound time signature. This is different than when we studied simple meters. So instead I want to skip to the third question and answer it, what the division level is, because that is immediately apparent from the time signature, 9, 8. The bottom number tells us the value of the division, in this case, eighth notes. And for compound meters, we group those divisions into groups of 3. So the division level in this case would be 3 eighth notes beamed together. Once you have that information, then you can determine the value of the beat. And it's going to be the single duration that is equivalent to the division level added up together. So what single duration is equivalent to 3 eighth notes? There is one answer, and that is the dotted quarter note. For all compound meters, your beat level will be a dotted value. Let's try 2 more examples. 12, 4. There are our 3 questions. To determine the number of beats per bar, we take the top number, 12, and divide it by 3. We have 4 beats per bar. That means you're going to use the quadruple conducting pattern for any meter whose top number is 12. Skip to the division level question, and we get that information from the bottom number of the time signature, in this case of 4, which represents quarter notes. There are 3 quarter notes per bar in 12/4. Then, to determine the value of the beat, you need to think what single duration is equivalent to 3 quarter notes. The answer is the dotted half. We will do one more example. 6/16. How do we interpret it? Those are our 3 questions. Number of beats per bar. Take the top number 6, divide by 3, and you get 2. This is a duple meter. We will use the duple conducting pattern anytime the top number is 6. What about the division level? The bottom number here is 16. That stands for 16th notes. And since it's a compound meter, we put 3 of them together and we can beam them. So it would look like that, 3 16th notes. And the single duration that is equivalent to 3 16th notes, comprising the value of the beat, would be the dotted 8th note.